Hey guys, welcome back to the videos. Today's video is on index notation, and that word or those words might be very unfamiliar to you, but we're going to learn what they are and what they mean through this video. So here is a little expression, 2 times 2 times 2. What do you notice about this? The first thing you might notice, well, what number is repeated? So what number is occurring time and time again? And that's the number 2. And how many times is it repeated? There's 1, 2, 3. So we're saying it's repeated 3 times. Now, if we wanted to write this in index notation, so we write it as a big 2 and a little 3 up in the top right of it. Now, it's above it. It's small 3. Okay, now the number that is repeated, we call that our base, and the number that tells us how many times it's been repeated, we call that our index. So if we were to label this one down here, we have our base being our 2, and our index, or another word for it, is power, and our index is 3 here. So what I want us to do now is work out the product of 2 times 2 times 2. Now, product means multiply. So 2 times 2 times 2 equals 8, and we call this the basic numeral. Now, there's a reason I'm saying this to you, and it'll make sense in the next one. Oh, no, in a minute. So I want you to write the following in index notation, so with a base and an index. Okay, so 8 times 8 times 8 times 8 times 8 times 8 times 8, I think I said that right. What's the base here? So if we remember back to our other one, the base is what's repeated every time. So our base is 8, and 8 occurs 6 times, so our power is 6. Let's do the next one, 3 times 3 times 4 times 4 times 4 times 4 times 4. This one's different because we have 2 different numbers here. That means we have 2 different bases, and the way that we write that is 3 to the power of how many times it occurs, so 3 to the power of 2 times 4 to the power of 5, because 4 occurred 5 times. Okay, I want you to pause it now, and I want you to do this one. Okay, so you should have got 6 to the power of 3 times 3 to the power of 5 times 2. Now 2 doesn't have any other number, it doesn't occur more than once, so we just write it as 2. Pause it again and do this one and then come back. So you should have had 12 to the power of 3 times 9 squared. So let's look at the different ways we ask you to write these kind of expressions. So the first way is our index notation, or our index form. So if it says index in it, and you'll hear it as either index form or index notation, you're writing it as a base with an index, with a power, with a small number. Okay? Now, if we were to write that with our multiplication symbol, our times symbol, we'd get 3 times 3 times 3 times 3 times 3, because it occurs 5 times. Now, this is bigger. This is a bigger sum, I guess. And so we call that expanded form. And the next one you should know, because we've worked that out, and we found that 3 times 3 times 3 times 3 times 3 equals 243. And before I said that's our basic numeral. Now, it's important that you don't make the mistake of converting from index form to expanded form by saying 3 times 5. 3 times 5 is 15. It's not the same thing. We're saying here that 3 occurs 5 times. Okay, so don't make that mistake. So let's do some examples of writing the following in expanded form. So 9 to the power of 3 equals 9 times 9 times 9. And we can see here that 9 occurs 3 times. 7 to the power of 4 times 8 to the power of 3. Again, we have 7 4 times 8, which occurs 3 times. 1, 2, 3. Pause it now and do this one. So what you should have had is 3 times 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 3. So it should have been 8 times. Pause it again, do this one. So what you should have had is 5 times 5 times 5 times 4 times 4 times 4 times 4 times 4. And hopefully that'll begin to make more sense as we move through the questions. So it's important that we learn how we say these as well. It's pretty simple. A to the power of 2, or a with the little 2, we say a squared. So if it's 2, it's squared. If it's a with a 3 above it, we say a is cubed. So for example, if this was a 5, we'd say 5 squared. If this was a 7, we'd say 7 cubed. A with a 4, we say a to the power of 4, or 7 to the power of 4, or 9 to the power of 4, whatever it is. 5, and from here on, we just say it's to the power of that number, to the power of 5. And that's the same. If we had a 20 up there, it would be a to the power of 20. Okay, we're going to look now at square roots. So a square root. To find the square root of a number is to find a number that when you square it equals the original number. Oh my gosh, that sounds so complicated. But it's not. It's really, really easy. We'll do some examples and that definition will make a lot more sense. So, the square root of 25. So, we're looking for a number when squared. So that means it's timed and there's two numbers. Equals 25. So here, if we go 5 times 5, well, 5 times 5 equals 25. So we say that the square root of 25 is 5. It's not 5 times 5, it's just 5, because we know that if we were to square that, we'd get 25. And remember, square means a 2 here, which means 5 times 5, because we have the number twice. Let's do some examples. Find the square root of the following. Square root of 25. We already did this one. Silly me. So we know it's 5 times 5. So the square root of 25 equals 5. And the next one, the square root of 64. What times itself equals 64? And this is where your times tables are going to come in really handy. So it's important that you keep practicing. So 8 times 8. So the square root of 64 is 8. I want you to pause it now and do this one. This one's easy. So what you should have found out is that, made a mistake there, 10 times 10, not 10 times 5, 10 times 10 equals 100. So the square root of 100 equals 10. Equals 10 there. Now, I want you to pause it and go find the square root of 16. So what times itself equals 16? 4 times 4 equals 16. Therefore, the square root of 16 equals 4.